work I'm representing today. My name is Tim Allison. I'm the tech lead on this project, DARPA project SafeDocs. We have lots of other folks doing lots of important work on this project, and I'm representing all of their work today. I'd like to start with some debts of gratitude. Sergey Bradas, the program manager on the DARPA project that this work was done under. I've had a lot of very fruitful collaboration with Peter Wyatt and Duff Johnson, so thank you. Lots of great feedback and collegiality with other performers on the SafeDocs program, and I'd also, of course, like to thank Common Crawl, and I'll talk about Common Crawl shortly. All right, so the goals of this talk, I want to demonstrate the state of the possible. Ideally, I'd like to transfer techniques, if not code, and I'd like to start discussion for next steps. This talk is a fire hose of information. It's aimed at lots of different audiences, including tech parser developers to industry business intelligence folks. So it's all over the place. But the goal is to start a discussion and figure out where to go from here as a community. Caveats, the numbers and stats are on different size samples kind of throughout the presentation. I had hoped to have all of the stats done on the 8 million file set via the talk. Didn't happen, but there's still enough here to demonstrate the state of the possible. So do not draw any conclusions from these slides. And the other thing is that there are some examples that include synthetic data, and those I have very carefully labeled. So goals and caveats taken care of. People want lots of files for many reasons. One is if you're inducing a grammar for a new file type or a new parser, dev testing parsers in development is important. If you have an existing parser, running testing, profiling, tracing on literal files, or using a bunch of files for fuzzing. And then across a broad range of files, it's a useful thing to be able to identify root causes, patterns within those files. So I'll talk about gathering PDFs, I'll talk about the observatory architecture, feature extraction, some basic descriptives on a sample of the corpus, comparing text extraction tools, and then discovery with some of the built-in features of Elasticsearch, and talk about next steps. All right, so fetching Common Crawl. First, what is Common Crawl? Common Crawl is an open source crawl of a large portion of the web. They do a crawl once a month. The crawl I'll be talking about is 3.2 billion pages or 3.2 billion documents, 360 terabytes. It's all available on AWS public data sets. Now, there are some known limitations. One is that files are truncated at 1 megabyte. So for files that are above that, they have a flag that says whether or not they were truncated. As part of gathering the documents, we got what was stored in Common Crawl unless it was truncated, in which case we refetched the files, and I'll talk more about that shortly. The other major limitation is in the representativeness. Obviously, the web contains web documents. It's likely missing subtypes that are designed for internal, proprietary, or sensitive data. So medical stuff, engineering, legal. We can think of all sorts of verticals where you would hope not to find documents on the web. The other limitations of the Common Crawl was effectively a convenient sample of the web. It covers a lot of the web. It's an amazing resource, but it gets what files it can. So if they're robots.txt files or if they're complicated websites, it may miss select portions of the web. So with those little hand wavy things, off we go. All right, so I took a random sample of 3 million URLs from that corpus, and you can see here the file types. PDF is the major non-text file type, and the percentage of PDFs vary quite a bit from crawl to crawl, from month to month, and that's kind of reflective of what the crawler was able to pick up that month. These are the top-level domains across all the file types. So com is the most common, then org, Russia, Germany, and so on. Countries. So I took MaxMind's free version of the GeoIP database, which can convert IP addresses to lat long and also country, and did a little bit of analysis with that. If you have the commercial version of that, or if you have telemetry that gives you better geodata, all the better. This is really proof of concept. So this is what all 8.3 million PDFs in Common Crawl look like when mapped, and see that point on GeoPrecision. Let's go look at that. That's the Cheney Reservoir. That's not where 1.6 million PDFs are hosted. That is where MaxMind points to if it can't find a more specific, more precise address than US somewhere. There's a funny story about that. Follow the link. And it's not funny if you were at the house where that middle used to point. All right. So in looking at this, I was looking at this and thinking, wow, that's kind of a tight border around France. And then it looks like the PDF density is getting further, or is decreasing as you move east. And I did some numbers on this, and those are all in the extra section. The takeaway is, yes, Germany does have a high percentage of PDFs in the Common Crawl data for this crawl. Switzerland and India actually have a higher percentage of URLs for PDFs. And Russia and China have fewer PDFs. Again, all of the math is in the back of the deck. I'll be happy to talk about how I measured that and what statistical methods I used for that. All right, so bytes, bytes, and more bytes. So for this crawl, there were about 8.3 million PDFs. 6.4 could be retrieved from the Common Crawl. You could just get the work files for those, so I downloaded those. Unfortunately, about 2 million had to be refetched, and that was, as you can see, a whole lot more data. So that's about 10 terabytes of data had to be refetched, whereas what's stored in Common Crawl, because they're truncating at a meg, is only 1.6 terabytes. This is a distribution histogram of file sizes. With the majority being smaller than 1 megabyte. We have 1.7 million greater than a megabyte, less than 10 megs, and so on. We had a couple of whoppers that's slightly over 1 gig. All right, so that's the data. So now I'll talk about the observatory. Our initial steps were the observatory was full cloud, very AWS-based components, so Athena, Kinesis, AWS Batch. We used S3 for storage. It was a massive framework that could pull in lots of files, do lots of processing, and it's really impressive. In talking to people, though, we realized that they may not have all of the AWS components. They may be in AWS GovCloud that doesn't have all of these tools, or might have subsets of these tools and so on. So we're moving more towards some kind of desktop and or hybrid single processor or a smaller thing that doesn't rely on the cutting edge AWS components. So we have various scales. At the moment, I'm working kind of hybrid, where I can do some of the processing on an EC2 instance, AWS EC2 instance, store to S3, have PostgreSQL on my laptop or in the cloud, and that's working out fairly well for this scale. All right, so the overall architecture on the left, we gather a whole bunch of files, we run a bunch of tools against them, we store the intermediate data in Amazon Athena or Postgres now, and then we do a big join on that data and ship it off to a search index, and we're using Elasticsearch as a service for doing that analysis. This is the observatory in a box. This is publicly available on my GitHub site. So I have all of the tool runners. Those are all Docker containers that will run against S3 or local file shares. I'm in the process of dramatically reworking all of that, so please don't download it all yet or any of it yet. And then each of those tools puts out its own table where we store whether there was timeout, whether it crashed, time it took to process a file, and then some data either from standard out or standard in. So for feature extraction, we have some basic regexes for some things. So this is pulling info out of PDF info. So we just wrote some regexes to pull out things and map those into fields for Elasticsearch. That's pretty straightforward. Where things got more interesting, though, was pulling structural bits of PDFs out of QPDF's JSON format. So for this, we run QPDF and then have some custom code that goes through and pulls out the keys. It pulls out the parents and keys. If a PDF object has a type field, then we are also now pulling out what we're calling the type key. So for an object that's of type pages, it has a count field, it has a proc set field, and so on, keys and values. And then also we were interested in filters and chained filters. So you can see we have that's an example of a chained flake decode CCITTFX decode filter. And then we also have a flag for max filter count, so that you can get a sense of how many PDFs and by what producers are using more than 2 filters chained, for example. All right, so basic descriptives. These descriptives are built on a random sample of 100,000 files. And this is just to give a sense, again, of what's possible. This is not the full set, and even if we did the full set, there's still limitations, blah, blah, blah. This isn't even that. This is just proof of concept of some of the things you can see in the data. This is still 100,000 files, so it's not tiny. So I was surprised by this. This shows that most of the PDFs in the crawl were created by, or at least those that have a created date, allege that they were created fairly recently. So if you want older files, you really have to go back to older Common Crawl crawls to get older files. Versions by year, this could be cleaned up. I agree, Duff, sorry about that. When we pull other Common Crawl earlier crawls, we'll get a better sense chronologically of what the distribution of PDF versions is by year. This gives you a general sense that you can at least do it easily in Elasticsearch. And this is the Kibana visualization framework. All right, these are the languages. So we ran Tika against these files, and the text that was pulled out, we ran automatic language detection against that text. And these are the detected languages in those files. And we're only detecting the primary language of a file. If a file is multilingual, we're still going with the dominant language in that file. All right, next little section is on comparing text extraction tools, which is something one would want to do if one had 8 million PDFs sitting around. So the first thing is, it's always a challenge to estimate the quality of text extraction or OCR without ground truth. And there are a couple of things, 2 things that are really useful. One is PDF specific, and the other is file format agnostic, which is quite general. The first one is unmapped Unicode characters. Apache Tika uses Apache PDF box under the hood. Tillman Hauscher showed me how I can count the number of characters that do not have Unicode mappings per page. And so we report that in our output from Apache Tika. And then the next thing that we use in Tika is something called the out of vocabulary statistic. And to calculate that, we gather the top 20,000 words for 120 languages from a large corpus. And then when we pull text out of a file, we run automatic language detection against it and say, oh, this is German. Well, if this is German, how many of the words that we've pulled out are in that vocabulary list for German, and how many are not? And that gives us a percentage of out of vocabulary. And typically, if your out of vocabulary is very high, it means that either it's not a languagey kind of document, or it could mean that something horribly wrong has gone on with text extraction. The same applies for OCR, and this OOV thing applies across file formats. It's quite convenient and very useful. And you can see from this link that Google effectively was probably doing it more than 10 years ago. So if you're not currently doing this thing, why aren't you doing it? The other thing to do is then compare output from 2 or more tools. And one of the things that I put together for this talk was a multi-comparer, which I'll be contributing back into Apache Tika shortly. It's not quite ready for that. All right, so first, unmapped Unicode characters. This looks like a fine PDF, but you can see that the statistics at the bottom, all of those characters have no Unicode mappings for them. So what kind of text do we get out of there? Junk! Out of vocabulary is nearly 100% across all 3 tools. Language detection is Romanized Urdu or Bengali. And yes, this is purely total text extraction on this is total junk file. You'd have to run OCR to get anything meaningful out of this file. This is an example of comparing text as extracted from different tools. This is comparing Tika versus Mutool, sorted by ascending overlap. So this shows you the files where Tika and Mutool disagreed the most. In some cases, you can look at the OOV, which is not in these columns, but you can, if you do the mental division between some of the columns, you can see it. And you can see that Tika is doing better on some, Mutool is doing better on the other. If we drill down on this particular file, Tika is getting 28% out of vocabulary, whereas Mutool is getting 100%. And you can see at the bottom with the compare thing that Tika and PDF to text have 95% overlap, so they have a high level of agreement, whereas Mutool is kind of an outlier for this file. And when you look at the extracted text, yeah, Mutool had some problems with the spacing, a very common problem, as we all know, with PDFs. So that's one way that you can look at comparing text extraction across a number of tools. All right, next part is discovery of features and patterns with some built-in features from Elasticsearch. So the first one has to do with just basic search, right? So forced entry, which is a major ODE that was just revealed. The write-up of this had this line that showed that there was a filter with chain flake decode, JBig 2 decode. Well, how many files in our corpus have 3 or more filter count? It turns out we actually do have some. We don't see the duplication of the same filter, but there are some PDFs with ASCII 85 decode, FLATE, and then CTI TTFAX. So it does happen, but not with that duplicate filter. But that's just something fun that you're able to do with this, is look for things that you have chosen to index. This is terms aggregation for creator tools by country, and this is just your regular facets or grouping by. Again, this does not represent reality. This represents 100,000 PDF, 100,000 sample of documents from Common Crawl, so hand wavy, hand wavy, hand wavy. But it's a useful way of looking at creator tools. A more interesting one, though, is what's called significant terms. And what this does is run statistics on the creator tools and say what creator tools are really limited to Germany, which ones are showing up in Germany and not showing up elsewhere. And this gives a slightly different view of the creator tools. For some, you'd want the first one. For others, you'd want the second one. But there are 2 different ways of looking at creator tools by country. We can also use prefix completion. So according to the spec, the font weight should be a whole possible values 100, 200, 300. And if you use auto completion built into Elasticsearch, you can see that some of the values have nothing to do with those. At least one file has bold, another one has 0, another one has 1,000. And the reality is all over the place. And the spec is not quite respected, as it were, by all of these files. All right. You can also look for spelling variants. So find me all of the most common keys, and then find spelling variants of those. And this is on synthetic data. This is data that is intentionally malformed. So we expect to find some crazy things like cap height misspelled. Subtype misspelled with a different capitalization is a real thing, but this is synthetic data. But it's a fun way of exploring variants within some of those fields. Now, this is rather interesting. So Prashant, one of my colleagues, identified some files where the pattern in the tree was root, dests, and then a direct object, which is not allowed according to the spec. So we put together a query to find out which files had that in our corpus, and then also to kind of rat out the producers for which that was the most common. And it turns out that WK-HTML to PDF was one of the most common. And they actually, Peter Wyatt found the bug report where they say they fixed dests and made that into an indirect object. You'll notice also this dvips. So dvips was the other producer, and they were doing the right thing. The structures that we had stored in our little keys and key parent value stuff weren't sufficient to do the correct search on this. And to do the correct search would have to index Peter Wyatt's PDF associations Arlington DOM, because this shows you that, at least for the first case, where you have root, dests, and a direct object, which is not allowed, that's the WK-HTML to PDF, whereas you are allowed to have a dests direct object if it's on a names, if it's root names dests, not just root dests. The joys of PDF. Anyways, but that's okay by the spec. So when we index the output from the Arlington DOM, we'll be able to do higher order file structure searches. All right, so next steps. We need to refactor the tools and integration to make it a lot easier to run. I didn't even have a chance to show, please forgive me, team. We have a user interface in front of this that makes some of the searching, some of the features a lot easier to get through. And we're working with Peter Wyatt and PDF Association on what kinds of things would be useful for this observatory. We need to nail down what final features, what final tools we want to have in this thing. Obviously, we want to make it extensible so that people can easily run their own tools and pull out their own information. And then we want to release this observatory in a box so that you can download it, do your own configuration, run it on your own file sets, whether you're grabbing Common Crawl or perhaps you have your own files that you want to run it on so that you can do something similar. And again, to go back to the beginning of the talk, I view it as success if some of the ideas in this talk are shared and transferred. You don't need to use my code for this to be a success from my perspective. This talk has been a fire hose. We have some time for questions, so we'll go to that now. But please do feel to reach out after the talk if you'd like a brown bag, if you'd like some kind of workshop on running Tika eval or anything else on this topic. This has been a fire hose. Thank you all. Thank you, PDF Association, for throwing such a fantastic event. Thank you all for listening. So now off we go, roughly on time, to the questions.
That was great, Tim, and you're actually kind of early. So
Yes.
I know you do have some extra slides back there. Did you want to take a couple of minutes and touch on those? You have some interesting data, I know.
Sure, thank you. Sure, so this is Search UI that Ryan and Michael are working on. So this is a more user-friendly interface to the data. The Kibana, Elasticsearch stuff is great for folks who know how to use Kibana, but we're trying to make it a little bit easier. So this is an example with auto completion of GS. You can see in the bottom right with the document count, so that if you type in a key, you can get some of those views that I showed where I was doing it manually with a bunch of JSON queries. The user front end will make that a lot simpler, so that you can do these things automatically. You can select files, you can download the specific files that are triggering it. And hopefully you'll be able to do those aggregations on producer, creator tool, country, that kind of thing. For each file, we have all of the different output from the tool. So this is TK means TK status, TK mime, but we also have PDF info, PDF fonts, QPDF, Arlington. We're folding in. We're also working with a couple of other folks who have commercial but publicly available tools. So PDF checker is one tool that we have also integrated. Here are some other fields from that. So I think that's the key thing that I missed. I think, yeah, I'm not going to run through the math problem on that. So I think we are, unless actually maybe I should. So very quickly, so PDFs by country. So the total URLs, Switzerland 17,000. There were about 160 PDFs from the Switzerland Common Crawl in that 3 million sample. If you expect that PDFs are evenly distributed across country across countries in this collection at 0.26%, then you would expect to have only 45 PDFs for Switzerland. So then you just apply chi-squared to that to get a statistical value that allows us to sort which countries are most different from the average. With Switzerland, India, and Germany being the top three for high levels of PDFs, Russia, China, and Canada being on the lower end of PDFs, again, for that sample, for that particular common crawl. So I did actually break out the math. I guess the one last thing to show is that another use of the common tokens can be summing across all of your files. So before we release Tika, we run Tika eval on the release candidate and the older version, and we look for major differences. So here we can see that for whatever reason, Tika, mutual, and PDF to text for the given detected languages, they're pulling out roughly the same sum of those common tokens. However, for some reason, Tika is not pulling out nearly as many. It's about 70,000 tokens short in Italian. And I haven't had a chance to dig into that, but that certainly leapt out to me. So that's something to look into. Yeah, so I think those are the slides that I pulled out that I think are the most interesting of the extras in the extras deck.
Great. All right, well, we can certainly get to the questions now, and we just want to make sure everybody knows that Tim's deck is, because he blazed through it pretty quickly, his deck is available for download from the handouts pod in this webinar. All right, so let's take some questions for you, Tim. First question here, how did you evaluate the file size of PDFs if Common Crawl truncated the files over a meg?
Yep, sure. So what we did is Common Crawl has a flag and it will tell you which files have been truncated. So we downloaded all of the files that Common Crawl said were not truncated from Common Crawl through their work files. And then the ones that it said were truncated, we took the URL and ran a crawler against all 2 million of those truncated URLs over the course of about a week and a half and pulled down 10 terabytes of data from the web at large. So that's how we got the file sizes.
Okay, and you made your router smoke as well doing that, I imagine.
Yes, yeah. I only got 2 calls from the SOC at NASA and JPL and another federal agency.
Right. Okay.
Not joking.
So next question from Common Crawl: what percentage of PDFs had such bad errors that they could not actually be processed?
Good question. I haven't, given that I've only run on some subsamples, I don't have reliable statistics on that. And it depends, of course, as you know, on the tool. For example, Caradoc, we know, will have problems with 40% of the PDFs, whereas PDF to text will quietly do as best as it can and not complain. So it's all over the place depending on the tool.
Okay. So what are how does this tool handle embedded files? Let's start with that one.
Sure. So currently we are ignoring embedded files. Tika has a really nice framework for handling embedded files. And we initially did a prototype where we were indexing the parent file and then all of the embedded files as well. For folks interested in file formats, the usual Tika embedded parsers just aren't that interesting. So, the XMP parser tries to get some of the more basic things out of XMP. We completely ignore font files and other types of files, some other types of embedded files. So in order to make that useful, we would have to add custom wrappers around font files, would have to probably have a custom XMP parser to yield the kinds of information that people want from in embedded file types. But after that, it's straightforward. But once we do that, we can also fit that back into the Tika framework, and it will be able to run um, ICC Max or whatever against ICC files and handle those embedded files uh, easily. And we will have a flag on the embedded documents that says, this embedded document was part of this parent document, and it's 4 levels down in the embedding within this file. So that's kind of an important next step. But we can't take whatever we have in Tika and just kind of apply it to this, because Tika focuses on text extraction, which is not really what this is necessarily about. This is more about the forensics or file parsing or other metadata around those embedded files.
Mhm. So what are your plans for making this this system public?
Sure. So we are currently in discussion. We would ideally we would make it publicly available. One of the challenges is that you have to understand Elasticsearch and Kibana in order to navigate it. We have the UI once that is at a state, and I think we're almost there of getting that out so that we can make that public. At that point, I'm hoping that we can at least make a version of that publicly available, perhaps with login, so that people can explore the files for 1 month of Common Crawl to get a sense of what's in there and what features they need, and give us feedback on that. We're also hoping to work with Common Crawl community perhaps to have a maybe once a year crawl where they extend the truncation limit so that we can gather full-size PDFs more easily. Now that we've done that refetch and have a better sense of the extent of the truncated files and how much data that is, it would be great if we could have that kind of data available, and then that would become not data that we're making available, but would be published as part of the usual Common Crawl publishing framework, which is AWS public data sets, so everybody can get that for free. But for the actual tool, we're still in discussion about making that public, at least with a login, so that people can kick the tires and see what's useful.
Okay, great. Another question here. What about encrypted files? I imagine you couldn't really parse them per se, but how were those accommodated or treated in terms of your statistics?
Sure. So that for this presentation, I did not do a filter on encrypted files. We do have a flag. We have different tools will tell you in different ways which files are encrypted, and we have the wrappers around those that we have an encrypted flag for the files. So with that, you can do all of the discovery that I gave examples of. You can say, which countries have more encrypted files, which producers are using encrypted files more than other producers, which versions have encryption, and you can do the same thing with signatures as well, so that you can very easily get a sense across either this corpus or your own corpus of distributions of encryption or signatures, tagged content, these other features that are kind of critical depending on what you're doing. But yeah, no, we are recognizing that files are encrypted and not doing anything else with them.
Yeah, but you can also actually, as you just said, there's a whole lot of interesting information you can learn about them, even though they are encrypted. That's very significant.
Yes,
Okay,
yes.
another question here. So you said that the number of PDFs varied from each Common Crawl.
Mhm.
Why is that, and by how much did it vary, or does it
Sure.
vary?
That's a really good question. So from my memory, I believe that some of the crawls had about 1 point some odd million. This crawl had 8 million. I think one crawl had 20 million PDFs. It all depends on what the crawler happened to grab in that month. So some of that has to do, with changing robots.txt. Some of that has to do with being able to follow JavaScript and complicated JavaScript websites. But I think we'd have to ask the Common Crawl folks, and I think Seb Nagel might be here. Obviously, it's not a participatory platform, but that's a question to ask Common Crawl folks about why there is so much variation. But it is large, and it's something to acknowledge.
Yep, interesting. Okay, next question here. So tell us, what's the maturity level of the observatory currently, and can we just walk up and download it and run it?
Sure. The maturity level is it runs on my laptop and on a particular EC2 instance that I've set up. It's not ready for downloading. It's not ready for running. I'm looking to do a major refactor where I'll be a lot of the stuff that's currently driven by code. I want to have the configuration driven so that there's a straightforward way of specifying an external tool like PDF to text or your own commercial tool, proprietary tool, so you can call that from the command line and then munge the the output of that. So no, it's not ready for use by everyone, but we are looking to package it over the next couple of months at least, so that we can at least get it working on, say, Peter Wyatt's desktop, and then hopefully make it able to be used by others. As it's currently set up, it does require, it's not a simple app because it is complicated. You're running 12 different tools that require, different dependencies, different libraries, all that kind of stuff. So it's a single Docker container for each tool with a common driver code behind it to extract the same, all of the, standard out, standard error, exit value, that kind of stuff. So it's not ready for transition by any means at this point, but we are working towards that. And I think we have enough here that we can go out and say, this is a really useful thing for lots of different questions, for lots of different uses. What would it take? Is there enough here to make this useful to transfer? Would you want to take this on? And if the answer is yes, then we can look at ways to make it easier to take on. Do we need PostgreSQL? Can we just put it straight from the tools into Elastic? Can we wrap that and make it easier to use? And those are some of the questions we'll be working with, and that's why we have the full team at JPL to make it useful for people.